Okay, so starting with question 5, one of the BC questions. Pretty simple presentation. We're given a table with a derivative, and we know the function is twice differentiable. We also know that f of 0 is equal to 0. Okay, for x is greater than 0, we're given the function h of x. Find the value of h prime of pi. Okay. Well, if h of x is going to be the integral from 0 to pi, no, I'm looking at the wrong one. It's the integral from 0 to x of the square root of 1 plus f prime of t squared dt. We're going to have to apply the fundamental theorem of calculus, where if you derive an integral, you cancel it out, and then you plug the variable, right? So now we have f prime of x squared. Technically, the chain rule always applies, right? You're always multiplying times the derivative of the limit of integration. But what's the derivative of x? So then it goes away, right? But the chain rule always applies. I'm just going to take this off. You get 1 point for doing the fundamental theorem of calculus. Now we want to find h prime of pi. And f prime of pi, according to the table, is 6, which gives us the square root of 37. That's your second point. Okay. Question B. What information does the integral from 0 to pi, blah, 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 provide about the graph of f? The integral provides the arc length of f. That's 1 point by saying that it provides the arc length on the interval from 0 to pi. That's the second point, saying the interval where the arc length is going to be defined. So 2 points plus 2. C. Use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f of 2 pi. Second time Euler method comes up in back-to-back FRQs. The last one Noah presented for us. So just like Noah, I'm also going to make a table. We know we need a point, right? We need x and y. You're also going to need a derivative because for tangent lines, you need the slope and a point. And you're going to be using the tangent line to approximate the next value. We're starting at 0. And we're going to use 2 steps of equal size to get the approximation for 2 pi. Whatever we give for 2 pi, that's going to be our answer. So when x is equal to 0, y is also equal to 0. It was given to us. The derivative is 5, which means my tangent line is 5x minus 0 plus 0. Use the tangent line to approximate the y value at pi, which is 5 pi. You get one method for, you get 1 point for doing Euler's method. Okay. The slope at x equals pi is 6, which means my tangent line is that. Use the tangent line to approximate f of 2 pi. $11 pi. That's your second point, bringing us to a total of 6. Okay. And then the last question. Find the integral. So far, after doing the review and you guys doing it, hopefully you think that this was pretty straightforward, because so far it has been. We want to integrate t plus 5 times cosine of t over 4 dt. Automatically, I see a product rule, which tells me I got to be doing integration by parts. Okay. You have to identify a part that you're going to derive easily and a part that you can integrate easily. You can always follow the Lipid rule. You guys remember? Logs, inverse trig, polynomials. So which one's my dv? This will help you choose dv. We're gonna choose cosine of t over 4. Now, whatever you choose for you, it needs to become simpler when you derive it, and this is gonna become very simple because du dt is gonna be 1, so du is dt. When you do the antiderivative for dv, there is a u substitution. Hopefully you can do it in your heads. This is going to be 4 sine of t over 4. If you can't do it in your heads, it's okay, work it out. Now, integration by parts, it's uv minus the integral of v du. So we got t plus 5 times 4 sine of t over 4. I'm just going to put the 4 in the front. 4 sine of t over 4. If we had limits of integration, you would have to integrate this and evaluate it from a to b, right? Just a review for you guys. Minus the integral of v du. You get 1 point for the structure of integration by parts. Oh, and you get 1 point for selecting your u and u dv. That's now 8 points. Yeah. Yes. Yep. That would work out as well. Okay, just finish integrating. So here we got 4 t plus 5 times sine of t over 4 minus, what's the antiderivative of sine? And what's going to happen with this u inside? Times 4. So 16 cosine of t over 4. Don't forget your constant right there. It'd be a shame to lose the last point because you forget the plus c. 9 points. Exactly. All right. The question we didn't get a chance to review yesterday. The series question. Okay. So we have a Maclaurin series, and we know that it converges. It converges to f of x in the interval of convergence. And we already know that going in, it converges. And we know that it has a radius of convergence of 6. Part A. Determine whether the Maclaurin series converges at 6. Okay, just because the radius of convergence is 6 doesn't mean it converges at 6. Because the endpoints could always be divergent. It can make the series a divergent series. So, part A. Plug in your 6. Six to the power of n. I'm getting deja vu, guys. Did we already do this? We did the first part? I see. Yeah, this is starting to feel very familiar. Maybe because I did it myself as well. I don't know. Look, those guys cancel each other out, leaving you with n plus 1 over n squared. You got to check if it diverges or converges. by doing a little comparison test. You can compare to 1 over n, which we know is a harmonic series, and it diverges. You can do a straight comparison test, or you can do the limit comparison test. But I do know that this one is going to be bigger. The original one is bigger than the harmonic because of the plus 1 is slightly bigger. And if my smaller series diverges, the bigger one diverges. The series diverges by the comparison test. Is it 1s or 2s's? Comparison. Okay, I'll leave it with 1. Oh, and I'll say at x equals 6. You get 1 point for setting up your series, and you get 1 point for the answer. Yeah. Oh, just take one of them and divide it by the other one. It really doesn't matter. It would be the limit as n approaches infinity. You could do the original one divided by the one that we chose, but we're gonna multiply by the reciprocal. But if your setup is the other way, technically it's gonna work as well. 1 over n divided by the original. It should also, yeah, your limit in both cases is gonna be 1, which means they both do the same thing. Part B. So it can be shown that f of negative 3 simplifies down to this series. And the first 3 terms of this series have a sum that is negative 125 over 144. Show that f of negative 3 minus s of 3 is less than 1 over 50. This is where recognizing, knowing your formulas and your concepts is going to allow you to recognize the setup really quickly, because this is the alternating series error test. So I'm just going to start with the regular formula that we learned. The absolute value of the series minus the partial sum of the series, that will produce the error, and the error will always be less than or equal to the next term. So if we're doing a partial sum with 3 terms, the error will be less than the 4th term. And they want us to show that the error is less than 1 over 50. So because they're giving us f of, the actual series is f of negative 3. But we're approximating the sum of the series using 3 terms. That means we should be looking at the 4th term. And that 4th term should be less than 1 over 50. Well, they already give us the simplified series, right? I highlighted it for you guys. Just plug in 4. We're trying to get the 4th term. So that would be 4 plus 1 divided by 4 squared times negative 1/2 to the power of 4. And we're going to show that it's less than 1 over 50. That's 5 over 16 times 1 over 16. 16 times 16 is 256, right? Yeah, it's 256. And, I mean, getting a common denominator is going to be hard. But what you could do to get a better comparison is to multiply the fraction, the smaller fraction, by 5. 5 divided by 250. That will give you a pretty good comparison, and it'll show you, hey, is this fraction actually, is the error less than the 1 over 50? Yes, it is. So yes, I'm just gonna take the question, f of negative 3 minus S of 3 is in fact less than 1 over 50. You get 2 points for this question. It looks like you get the first point by finding your fourth term and by confirming it. Okay. All right. Part C. Find the general term of the Maclaurin series for f prime, the derivative of f, and then find the radius of convergence. Okay, so let's go ahead and start with the original series. The original series for f, so that's going to be the n plus 1 times x to the power of n divided by n squared 6n. That's f of x. Right? I'll put it right here. F of x equals. We need to find the general term for the derivative. So all you got to do is get a derivative with respect to x. That means all the n's are constants, right? All you got to do is bring the n down and subtract 1 from the exponent. The denominator is all constants. Don't do anything with the denominator. Simplify it. N plus 1 times n to the power of x minus 1. I guess I could have just canceled it already, huh? Here. I could have done that. In the rubric, they actually do a different simplification. No, they don't. Never mind. Yeah, I'll just cancel that. Let me see. N 6 N. That would be the first point. Finding the general term for f prime. We got to find the radius of convergence. Find the radius of convergence for the Maclaurin series. Okay, one thing that maybe we haven't, I don't know if it came up in the notes, but the radius of convergence for f and f prime are the same. So the radius of convergence is 6, right? Yeah, 6. Yes. Just wrote it. Yeah, they didn't go into the interval of convergence. Okay, the last part. The last part takes the most work. Let g of x equal that. Use the ratio test to determine the radius of convergence. This series is a little bit different than the original one, so you just gotta run through the whole test yourself. So, oh man, I'm kind of running out of space. I'll try to do it here. Okay. The limit as n approaches infinity, we're gonna be doing a of n plus 1 divided by a of n. That's gonna be n plus 2 times x to the power of, look, I'm gonna skip a step, but technically this is what you should be doing, and it's gonna become 2n plus 2. So I'll just put 2n plus 2 divided by n plus 1 squared times 3 to the power of n plus 1 divided by a of n, or multiplied by the reciprocal. Okay, Simplify it down. N plus 2, x to the 2n, x squared, n plus 1 squared, 3n, 3 to the 1, n squared. Okay. Yeah, sorry, it went a little fast. Well, we can simplify the 3 to the n's. We can simplify the x to the 2n's. Okay. And when I take the limit to infinity, well, we technically have an n cubed on top and we have an n cubed in the denominator. So that's going to leave us with the absolute value of x squared over 3 is less than 1. Normally from here, you would take off the absolute value and set up your interval. But that's going to be a problem. We're going to end up with a negative inside of a radical if you do that. So then I just keep going. The absolute value of x squared is less than 3. So then x is going to be less than the square root of 3. Again, yeah, if I would have taken out the absolute value, we would have ended up with the square root of negative 3, which is not a real number. So in that case, just ignore that one. And there's your interval of convergence. They also want us to find, they want us to find the radius. So the radius of convergence is the square root of 3. Technically, when you take the square root of an inequality, you do get a plus or minus radical 3. So right here, they don't show it in the rubric, but you could do that because we are taking the square root of an inequality. Thus, the radius of convergence is square root of 3. You get 1 point for setting up the ratio test. You get 1 point for applying the limit, and you get 1 point for the radius. I didn't have to check the endpoints because the question wasn't to find the interval, it was to find just the radius. So it didn't matter if these were going to be included or not. All right. Yeah, there you go. Questions 5 and 6. Happy learning, guys. Happy learning.